Okay. Okay, so good morning. Okay. Boleh nampak? Slide boleh nampak? So I think sekejap I check. Okay. Okay, so long we didn't have physical class. I think subject ni I think first time untuk saya. I think even though I already teach 3 years, 3 batch. I think COVID time memang tak ada ni lah physical class. Okay, so I think this subject is a theory subject and it's suitable for us to learn face to face. Okay, even the lab. Okay, so my class I will teach in English and also Malay. Okay, so kebanyakan term dalam bahasa English. Okay, so I cannot directly translate. Nanti bahasa dia akan lain lah. Okay, so I expect you to answer in English. Okay, in your exam. Okay, so if you really can't answer, then you try to answer. Okay, because the term you cannot really directly translate. Okay, so I think last week we stopped at this slide. Okay, I couldn't really finish chapter 1. Okay, only few slides left. I think page 18. So total got 22. Okay, so I just want to quickly finish this. Okay, so I think camera boleh cover. So board and also boleh. Okay, so we have seen. Okay, we have in chapter 1, introduction to thermal fluid science. Okay, thermal fluid science is actually the science of thermodynamics. Okay, fluid mechanics and also heat transfer. Okay, so you can see work. Work is a form of energy, can simply be defined as force times distance. Okay, so formula dia force times distance. Okay, F times D. Okay, so all these are physics. Okay, so kalau you tak ingat lagi, so I hope you can go and revise your physics. So ambil buku physics form 4, form 5, try to revise a bit. Okay, so W equals to FD. Okay, F times D. So force times distance. Okay, so therefore the unit is Newton meter. So Nm. Okay, which is called as joule. Okay, so boleh panggil juga joule. So 1 joule equals to 1 Newton meter. Okay, and a more common unit of energy, energy in SI is 1 kilojoule. Okay, dalam SI kita ukur gunakan kilojoule. Okay, so 1 kilojoule equals to 10 to power of 3 joule. Okay, so that's another term called BTU. Selalunya jumpa BTU ni dekat mana? So have you experienced BTU? British Thermal Unit. Okay, so I have said, so there are two types of measurements. One is SI, okay, SI and also British measurements. Okay, so BTU is under this British measurement. Okay, so BTU normally, if you work in aircon shop before, like just like you're working and you have seen this BTU term when you're measuring how many horsepower. Okay, biasa dengar tak aircon horsepower? Okay, 1 horsepower, 1.5 horsepower, 2 horsepower, 2.5. Okay, so BTU is used to measure the volume of the, okay, let's say we are taking this room. Okay, so ambil bilik ni. Okay, so bilik ni ada keluasan. Okay, volume. Okay, keluasan, maybe you keluasan bilik ni kira macam mana? How you measure the area of this room? Okay, so panjang kali lebar. Okay, so panjang kali lebar, volume kali tinggi. Okay, so you can get the volume of this room. Okay, for this particular volume, how many horsepower is needed is measured by BTU. Okay, so I'm not really going in detail about BTU, but if you want to know how the aircon engineers, okay, air conditioning engineers or air condition shop, they are measuring how many horsepower is enough to cover. Okay, so bila ini tak boleh letak 1 horsepower. So I think ada 100 plus student. Okay, so your body is generating it. So after some time you akan rasa panas. Okay, you akan rasa panas. So 1 horsepower is not enough. So maybe for this particular size, based on what I know, so maybe 2.5 will be sufficient. 2.5 horsepower. So macam mana nak calculate tu in mathematical way? So we are using BTU. Okay, British Thermal Units. Okay. Okay, yang ni you boleh baca lah kat bawah. So BTU is used in calculation of air conditioned horsepower. Okay, so I letak dekat bawah lah. Okay, so I think the top I already explained in the previous lecture, so I'm not really going. Maybe boleh bagi tahu sikit lah. Okay, so in moon, okay, dekat bulan, so your body weight will be 1/6. Okay, so I ada bagi tahu in last week's lecture. So if you are trying to lose weight, okay, so you cuba diet, you cuba exercise, tak dapat lose weight, so I give you a suggestion, you can go to moon. Okay, boleh pergi ke bulan, so automatically your weight will be 1/6. So if you are 60 kg in the on the earth, so you will only be 10 kg. Okay, so the weight of a baby. Okay, so if you really want, I can strongly suggest for you to go to moon. Okay. Okay, so walaupun yang ini adalah simple, so in the past year ada satu soalan berkenaan dengan yang ni, and it's a C6 question. C6 question meaning complex question related to this. So you need to come up with some solution. Okay, so the solution is obviously not transferring to moon. Okay, so it's not a solution, but it's something related to this. Okay, so when we are studying this lecture, so try to brainstorm, try to think. The WH question tahu kan? What, why, where, okay, which, okay, how. Okay, so try to ask more questions because this subject is related to science. So science, you can ask a lot of questions. Boleh tanya banyak soalan. Okay, so banyak soalan. So as you are studying this slides, so try to ask questions. So try to ask question, kenapa macam ni, kenapa macam ni. So then you will get a better understanding of this subject. Okay. So boleh tengok dekat sini lah. I think some of the explanation related to BTU, how you can convert it to SI, but it's not so important. Okay, so we have one more to cover, dimensional homogeneity. Okay. In engineering, all equation must be dimensionally homogeneous. Okay, so this is every term in an equation must have the same dimension. Okay, so this is for mathematics. Okay, kalau ada satu persamaan, so you have an equation, so you only can add two things with the same dimension. Okay, so tak boleh campur meter dengan kilometer sekali. So you need to convert first. Okay, once you convert, dua-dua pun meter, baru you boleh tambah ataupun tolak. Okay, that is what we call as dimensionally homogeneous. Okay, so in thermal fluid, okay, dimensionally homogeneous is important because it's a part of physics. Okay, dalam physics, so I have told you this subject is using a lot of mathematics. Okay, ada banyak mathematics, but I try to minimize because my main aim for you is to make you understand. Okay, so I bukannya adakan satu subjek matematik. So mathematics, I think you already have engineering mathematics that you are taking. So I'm not really testing mathematics. So most of my questions will be in C5 or C6 question where I need to trigger you to think. Okay, so I akan tanya in my lecture, I will give a lot of information that is not available in the lecture note. So that's why I always encourage you not to miss class. Okay, I think last week pun ada ramai yang bagi tahu. So ada activity ni. So try not to skip class. Okay, so I try my best to upload. Okay, I don't know whether other lecturers are doing this, but I try my best to upload all my lectures. Even though I bought Synchronous, I put some effort to bring my tripod. So I think balik ni I can upload dalam YouTube, so that if you miss class, go back to listen. Okay, so I only can do my part. Okay, whether you want to listen or you want to understand the thing better, it's up to you. I tak boleh force, because if from beginning you are not doing that, nanti study week baru nak listen to all the video, so I think you pun no motivation nak dengar kan. So all the video pun 2 jam lecture. So I always encourage you. Okay, normally during my university time, okay, I study in Unimap. Okay, I study in Unimap. I memang pernah duduk macam ni last time. So how I normally will do, okay, before the class start, I will study first the lecture note. Okay, so katakan hari ni chapter 2. Okay, I normally will study first the lecture note. Whether you understand or don't understand, that's different story. Belajar dulu. Okay, belajar dulu, then come to class. So mai ke class, then the lecturer will teach you. Okay, selalunya lecturer ajar tak faham kan. So that's because you didn't study the lecture note first. Okay, so baca dulu. I already gave all the lecture note. Sampai chapter 9, I dah siap divide into parts. Part 1, part 2, part. Okay, so that particular week, if I say part 1, I only akan cover that particular slides. Okay, normally not more than 30 lah. Macam hari ni I think only 20 something, I think belas. Or sorry, 23. Okay, so it don't take a lot of time for you to study. So baca one day before. Okay, so morning class, baca at night. So at night you read. Okay, so baca, whether you understand or not, so at least you will have a 50% understanding of what we going to study the next day. Okay, so come to class when the lecturer is teaching. So you focus more on the thing that you don't understand when you read the slide. Okay, so then you will get a better understanding. So I always encourage my student, even belajar computer programming pun bawa laptop ke kelas. Okay, buat coding on the spot. Okay, last time I teach computer science, computer programming. So I think Sir Eddie teach you, right? Okay, I think the class is divided into 2. You think? So last time, so I always encourage student to make mistake. Okay, buat mistake, learn. So when you do mistake, so you will when you are learning, so the weight will be different. So sampai habis sem you takkan lupa. If you do mistake and you learn. So kalau you tak buat mistake, you learn from other people, so you learn from the lecturer, selalunya dia tak lekat. I think maybe 1 week, 2 week, then after that you will forget. Okay, so dimensional homogeneity. Okay, so you want to avoid errors. Okay, so if your equation is not dimensionally homogeneous, so it will create error. So macam ni lah. So one of the error. Okay, so energy in kilojoule. So 25 kilojoule plus 7 kilojoule over kg. So which the dimensional is not homogeneous. So it need to be either kg over kg or kg. Okay, so then you can add up. Okay, so you need to check the formula. Okay, so check the formula. So you boleh baca lah yang ni. Okay. Okay, so an example, I think better I go this side. Akan nampak. Okay, so an example. Okay, this is very short. Okay, so a tank is filled with oil. So boleh baca lah dekat sini. So I'm not really going through. Okay, so ada volume. Okay, you have the density values, and they ask you to find the mass. Okay, so you multiply. So this is the formula. So mass equals to density times volume. Okay, and you are getting this. Okay, so this is dimensionally homogeneous or not? Homogeneous ke tak? Yang ni homogeneous ke tak? No. Tapi boleh buat kan? So selalunya darab and bagi it can be done even though it's not the same because you can cancel. So meter cube can cancel with meter cube, so end up the mass will be in kilogram. Okay, so multiplying is okay if the unit. So kalau yang ni kilogram per meter cube and yang ni temperature Celsius, cannot. Okay, it will derive another unit at the back. Okay, but if you want to cancel out things, so it can be done. Okay, so unit conversion ratio. Okay, so that's a term called unit conversion ratio. Non-primary dimension can be formed by suitable combination of primary dimension. Okay, so you can combine. Okay, yang ni pun fizik. Okay, so two primary dimension. Okay, like kilogram, meter and second, you can combine to form a non-primary unit or secondary unit. Okay, so yang ni kita abaikan lah. So we are only focusing more on the SI unit. So we are not focusing on the British. Okay, so it can be expressed. So if you want to make this thing, so this is a primary unit. So you want to make it 1. So you rearrange yang ni lah. Okay, so yang ni semua ke bawah. Okay, Newton over all this. So equals to 1. So you boleh dapat yang ni. So you can use this to times with whatever conversion that you want to do. Okay, macam ni. So you want to times kilogram with meter per second square. Okay, so you want to times this, then you just darab dengan yang ni. Okay, so this thing you get from here. So you cancel out whatever things that you are not there, they are not there. Okay, macam kilogram cancel dengan kilogram, so meter cancel dengan meter, so second square cancel dengan second square. At the end, so only Newton will be there. So automatically this thing can be converted to Newton. Okay, that's the function of unit conversion ratio. Okay, and it only can be done using a primary unit. Okay, so in the upcoming chapters, chapter 2, chapter 3, so you will be dealing with unit conversion ratios. So unit conversion ratio is like a tool, macam toolbox kan. Dalam toolbox ada tools. So you can use this unit conversion ratio to save time. So kalau tak, you kena darab dengan ni, kemudian kena buat manually to convert. So you just do in one step. Okay. So ada soalan? Okay, chapter 1. So this is last week's chapter. So I just had around 4 slides for me to cover. Okay, ada soalan? So kalau tak ada soalan, I think we can go to today's lecture. Okay, how many of you already seen the lecture note? Okay, so maybe you don't know today, but next week, the upcoming classes, please go through at least once. Okay, baca dulu. So try to understand as much as possible. Okay, so today we will enter to chapter 2. Okay, fluids and physical properties. Okay, so fluid and physical properties is like you are covering most of the physics stuff. Okay, so you try to understand some things are new. Okay, some of the things are new, so you try to focus, because some of the things that we will be studying in this chapter, we will be studying in the upcoming chapters. Okay, so this subject, as I said, previously it's considered as one of the killer subject. Okay, so ada banyak benda yang teori, so banyak benda about principles of thermal fluid science. Okay, so ada banyak benda yang you kena ingat. Okay, that's why the previous batches couldn't really score. Okay, so dia sama macam apply mechanics lah. Okay, so apply mechanics siapa aja? Sir Saifuddin. So apply mechanics pun ada banyak benda yang you kena buat kan. Okay, but apply mechanics is more on the calculation side. Okay, so you kena calculate ni. So but this subject is more on the principle. Okay, principle of physics. Okay, so you akan belajar a lot of physics dalam chapter ni. So okay, maybe we will start. Okay, what is a fluid? Apa tu fluid? Benda alir. Okay, siapa boleh bagi tahu? Nak panggil nama ke? Boleh kot nah. Muhammad Aiman. Kan? Bukan. Terkejut dia. Aiman siapa? Which Aiman? Muhammad Aiman bin Mat Lazin. Okay, you can say it's okay. Okay, bagi tahu je. So it's okay. Layman term, no need to be technical. Apa yang you faham kalau I bagi tahu you fluid or benda alir? So, jawapan ada kat sana kan? Baru nak baca. Okay, so selalunya kita ada misconception ni. So not only to Aiman. Okay, we always think fluid means cecair. Okay, so fluid is actually liquid and gas. So it can be either one. Dia boleh cecair dengan gas. Okay, both are considered fluid. Okay, so kalau ada siapa-siapa bagi tahu fluid adalah cecair, so try to correct them. So fluid is actually, it can be liquid or it can be gas. Okay, so macam yang bagi tahu dekat sini lah. The substance can exist in 3 primary phase. Okay, so any metals can be either solid, liquid or gas. Fizik kan? Bukan benda baru kan? So pepeja, cecair ataupun gas. Okay, so any substance can be either solid, liquid or gas. Okay, macam water. So water dalam solid apa? Okay, ice. Okay, so ice. So dalam liquid, okay, water lah. Okay, and gas, wap air. Okay, gas vapor. Okay, all 3 are water. Okay, so but it can be in 3 different phases. Okay, so sama lah. A substance in a liquid or gas phase is referred as a fluid. Okay, so try to soalan ni soalan yang selalunya akan keluar. Okay, what is fluid? So very simple question. Okay, so waktu tu jangan, if you say is cecair ataupun liquid, so you only get half mark. So it's actually combination of both. Okay, so it can be either liquid or gas. Satu chapter yang kita dah remove dari syllabus you, so it can be in between liquid and gas. Okay, separuh liquid, separuh gas. So we already removed that from your syllabus, but for now it can be in a liquid or gas form. Okay, so distinction between a solid and a fluid is made on the basis of the substance ability to resist the applied shear or tangential stress. So kalau you tengok, I'm not really going to this. Okay, so solid. So kalau you tengok solid, so ini adalah solid. Okay, solid can resist a applied shear stress by deforming but will not continuously deform. So let's say you have 2 plate. So katakan you ada benda ni. Okay, so this is a solid. Okay, solid, you letak dekat sini. So you apply force. Okay, force in tangential macam ni. Okay, on top. So maybe it will deform, tapi dia takkan berubah bentuk. Okay, it will not continuously So this is like solid. Okay, solid. If you apply a force, it may be deform a bit, but after some time it will go back to its original form. Okay, so that is solid. But if liquid, okay, if fluid is liquid and gas, if you apply a force, it will be continuously deform until it become uniformly stable. Macam air lah. So kalau you tube, okay, tube tangential macam ni, okay, tube dari sisi, so you tube, it will move until dia jadi balance, kemudian dia akan stop. Okay, so that's the slide, that's what the slide is explaining. Okay, so stress is defined as a force per unit area. Selalunya kita cakap kan, stress. Apa itu stress? Okay, stress in technical way. So stress is force per unit area. So you ada satu area and you continuously put pressure on that. Sebab itu kita dapat stress. Stress sebab dekat area ni selalu stress. Kan? So you are applying force at one particular area continuously over time. So it become a stress. Okay? So yang ni semua you boleh baca lah. So I just highlighting the important point in yellow. Okay, so normal component to the force is called normal stress. So kalau you tengok dekat sini gambar ni, okay, so you have a area and you are applying a force. Okay, so force, okay, benda ni you pernah tengok kan dalam fizik. Okay, so normal and also tangential. So normal force adalah Fn and tangential force adalah Ft. Okay, so this is same in line with the surface and this is perpendicular. Okay, 90 degrees. Okay, so if you see, so this is a normal stress. So a normal component. So meaning is a 90 degrees to the surface. Okay, we call it as a normal stress. And tangential stress kita panggil as shear stress. Okay, this is same. So kalau yang ni, okay, I tuju dekat sini. Okay, yang ni adalah apa? Force apa? Normal. Okay, normal. So like this. So like this. So kalau you want to push this, so this is tangential. Ataupun kita panggil as shear stress. So dia ada few names. So in this chapter, so you will be studying the terms. Terms yang kita akan gunakan throughout this chapters. Lagi ada I think dalam 7 to 8 chapters. So all these terms you will be continuously hearing. Okay? Okay, so the formula for normal stress. Okay, apa simbol ni? Dah bagi tahu kan dekat sini. So the symbol is rho. Okay, so it's a Greek symbol. Okay, rho equals to normal force divided by the area. Okay, so area ni adalah yang benda bulat ni. So Fn is this. So you Fn divided by dA. So dA is a small area. Okay, so you get the normal stress. And shear stress or tangential stress, selalunya kita akan gunakan tangential stress. Kita tak akan gunakan shear stress lah. Tapi kalau dalam exam dicakap shear stress, so you automatically you need to know that we are referring to tangential stress. Okay? So shear stress, simbol dia adalah tau, dia macam T. But it's a Greek symbol, bukan T yang kita gunakan. Okay? So it's a tangential force divided by dA, the area. Okay, in a fluid at rest, the normal stress is called pressure. Ini yang kita selalu dengar kan. So memang something yang kita selalu dengar daily, stress, pressure. Tapi we don't know what is that. Okay, so normal stress. So macam I bagi tahu tadi kan. So 90 degrees to you. So keep on you getting it. So we call it as a pressure. Okay, a fluid at rest is at a zero shear stress. Maksudnya katakan fluid, gas, or selalunya gas dia boleh berjalan lah, dia boleh bergerak. But if liquid, if it's only in one particular place, it's not moving, so kita panggil as fluid at rest ataupun static fluid. Okay, we will study in chapter 3. So it is having a zero shear stress. Maksudnya dia tak boleh bergerak because it's already static. Dia tak bergerak. So dia punya tangential stress ataupun shear stress adalah zero. Okay. When walls are removed, a shear stress develop as a liquid move to re-establish a horizontal surface equilibrium. So macam air tadi, so katakan dia just ada dekat satu tempat, but you are applying a shear stress. You tube dari tepi. Siapa akan jadi dekat air untuk air tu? So dia akan bergerak, then it will reach a horizontal surface equilibrium. Dia akan maybe tadi dia dalam bentuk bulat, so you tube, maybe it will form a bigger circle. Macam tu lah. So it will stop, it will move until it re-establish a horizontal surface equilibrium. Okay. Selepas dia dah sampai dekat surface equilibrium ni, dia akan stop sampai dia dapat another tangential force. You buka kipas, so dia bergerak lagi. Okay, so that is how what is a fluid about. Okay, for this slide. Ada soalan? I go as slow as possible lah, so that you boleh understand. Okay. Okay, the front part of the chapters are physics, so maybe something yang you already tahu. Yang belakang-belakang tu maybe something new. Okay, so I just try to teach you some physics first. Okay, so liquid, so I already told you fluid is consists of liquid and also gas. Okay, so dia wujud dalam dua fasa. Okay, two phase. So one is liquid. So what is liquid? A group of molecule can move relatively to each other. Okay, so you tahu pergerakan molekul dalam cecair. Okay, so it will be move relative to each other, but the volume remain relatively constant, meaning it won't go above this. So the volume is like a constant because strong cohesive force. Apa tu cohesive force? So what is cohesive force? Kalau you tak boleh jawab, I tanya dalam exam. Okay, so I take note. So what is cohesive force? Daya tarikan antara molekul dalam cecair, kan? So kalau compare liquid dengan gas, mana daya tarikan dia besar? Cecair ke ataupun gas? Cecair. So that's why it is a bit intact. Okay, ataupun dia kita cakap as volume remain relatively constant. Okay, because of yang ni kenapa dia constant? Sebab ada cohesive force in between the molecules. As a result, a liquid takes the shape of the container it is in. So maksudnya kalau you ada satu container, satu bekas, you masukkan cecair, dia akan follow bentuk cecair, bentuk bekas tu. Okay, kalau botol ikut bentuk botol. Okay, and it forms a free surface. Free surface adalah yang atas ni. So antara your surrounding and also the liquid. So you having a free surface. Free surface ni important in chapter 3. Okay, because we will be studying about static fluid. Okay, in a larger container in a gravitational field. So yang ni kalau dalam gravitational field. So kalau dekat angkasa lepas, so dia takkan ada free surface ni. Sebab itu you tengok angkasawan, so dalam kapal angkasa, so they will kalau you you pour water kan, so dia akan macam dia akan floating, so it will be floating. So this is only applicable in the gravitational field. Okay, so this is for the liquid. Okay, for the gas, kalau you tengok dia ada bintik-bintik ni. So what's the difference, main difference between liquid and gas? So kalau you tengok dekat gambar ni, so what's the main difference? Apa yang dia tak ada? Gas tak ada. Free surface. So maksudnya kalau you buka penutup dekat atas ni, gas ni akan keluar. Because it's not having a free surface. So free surface is like a boundary where the molecule cannot break. So molecule ada dalam ni kan. Free surface ni dia macam akan so molecule ni dia akan cuba pecahkan free surface ni. Tapi dia tak dapat overcome. So dia stick dalam ni. But for gas, it's not having a free surface and the gas molecules can go out to the surrounding. Okay. So the walls of the containers and it fills entire available space. So meaning if you put a gas inside, it will follow the apa tadi? Shape of the container, but it's not limited. So kalau you buka penutup ni, macam liquid dia takkan keluar, but gas will go out. Because kenapa? So if I ask why the gas can go out of the container if the lid is open, because the cohesive force is very small. Okay, daya tarikan antara molekul adalah sangat kecil. Okay, so dia macam tak ada gravitational force dalam tu lah. Okay, it's between the molecules. So a gas cannot form a free surface. So no free surface, and because of that is compressible. Okay, so compressible maksudnya boleh mampat. Okay, so you can put a piston and you can compress it, but liquid cannot. Okay, liquid cannot, and the density are not constant with pressure. Okay, so gas and vapor are often used as a synonymous word. Okay, so if in your exam I am saying gas or vapor, so you need to automatically understand that I am referring to a gas. Okay, boleh? So far boleh follow? Okay, so take 5. So I know morning is very challenging time, but you can just bring food. Okay, so just feel free lah. Okay, so we are not in the school. Okay, so if you want to bring food and eat in the class, it's okay. So okay, so normally I will give 5. So 5 minutes of break in between, so that you can take a deep breath. So you now bangun, exercise pun boleh. Okay, so I will continue to read names. Okay, Muizin. Okay, ada. Okay. Muhammad Amar. Tak perlu. It's okay. Muhammad Amar ada? Tak ada. Dah stop ke? Pergi mana? Sukip. Okay. Because the student like tak contact saya lah. Okay, Muhammad Faiz. Sukip juga? Tak ada. Okay, Ku Musfira. Ada. Muhammad Firdaus bin Muhammad Farid. Muhammad Firdaus? Ada? Tak ada juga. Okay, Muhammad Syazwan Ilmi. Muhammad Umar. Muhammad Wafi Hakim. Muhammad Zaid. Muhammad Zahirul. Nik Muhammad Adam. Nik Muhammad Al-Fatih. Nik Muhammad Akiki. Nirvish, Nisa Akila, Nur Alia, Nur Aimi, Nur Ain Najwa, Nur Ain Najwa. Ada. Nur Aisyah, Nur Dini, Nur Fakira, Nur Afizato, Nur Uwaina, Waina ada. Nurul Alia, Nurul Aura, Nurul Farain, Nurul Farain. Ada, tak ada? Ada? Tak nampak tangan, sorry. Nurul Shakira, Parameswaran, not that. Premitra, Pritika, Presley, Sharmila, Said Azimi, tak ada. Syarul Azlan, Siti Nurliana, Steven, Sufyan, Syarul Anwar, Tan Yu Chen, Tilagan, Tiwagar, okay. Umar Razi, Unku Arman Shah, Wan Muhammad Irwan, Wan Nur Kamarina, Yap Kalok, Zamir Usairi, Zarik Iskandar, Demam. Okay, so kalau you tak dapat ada, so you need to produce valid evidence lah, MC ke ataupun surat dari universiti. If not, it will be considered as absent. Okay, so ada nama yang saya terpanggil because dalam sistem ni ada 94 orang ni je. Ada yang nama saya terpanggil. Semua saya dah panggil sebab dalam WhatsApp group macam ada 100 lebih orang. So which one I need to follow? So siapa yang ghost voter ni, pengundi hantu? So I just follow the system lah so far. Ada nama yang saya tak panggil tak? So I pun tak tahu lah. I think must wait until the second or third week, then only this list will be finalized. But so far only ada 94 lah. Okay, so can we continue? I think almost 10 minutes dah. But it's okay. Okay, so we'll continue. Physical properties. Okay, so we will study some of the physics terms that we will use throughout this chapter. Not only this chapter, throughout this course. Okay. So density and specific property. Okay, density dalam bahasa Melayu apa? Ketumpatan. Okay. Okay, ketumpatan. Okay, I think you all study dalam bahasa Inggeris ke bahasa Melayu? Okay, bahasa Melayu I think you are more familiar lah, but you just need to relate. Okay, just need to relate. So density is actually ketumpatan. So it's actually the quantity of metals contained in the unit volume. Okay, you normally have a volume of a particular substance. So how much is the quantity of the metals inside? Okay, so it can be expressed in 4 different ways. Okay, so I explain dulu, but throughout the course you will somehow you will learn. Okay, kalau dia macam terlalu banyak info, you try to understand as much as possible. Okay, and you can go and listen back to the video, so that you can get some important info. But the important stuff I already highlighted in yellow. Okay, dalam warna kuning ni adalah some of the important. So main is the definition. Okay, because in exam I can ask, so define mass density. So you kena tahulah sedikit sebanyak yang you boleh answer. So it's actually the definition of mass density. So kalau you tengok dekat sini, so the density can be represented in 4 different ways. Dia ada 4 jenis density. Okay, so first is related to mass. Apa tu mass? Jisim, ya, betul. Okay, so mass density. So mass density ataupun simbol dia. Okay, this is something important. Simbol rho. Okay, mass density symbol dia adalah rho, is defined as the mass substance per unit volume of substance. So maksudnya you ada satu mass, okay, per unit volume. Okay, dalam satu volume of a container, berapa banyak mass yang you boleh masukkan. Okay, that is what we call as a mass density, or we call another term is degree of compactness. Apa itu compactness? Kepadatan. So how much you can boleh mampat. Okay, so katakan you ada satu bekas, you masukkan a mass, okay, you masukkan a substance, then you try to compress it. So the degree of compactness of the substance is what we call as a mass density. Okay, so unit dia kilogram per meter cube. So unit dia pun important, because sometimes in the question we don't say mass density, tapi kita bagi from the unit, you boleh understand. You can understand that we are referring to mass density. Okay, so unit dia adalah kilogram per meter cube. Okay, so typical value, some of the important substance, water, selalunya kita akan gunakan term ni. Okay, for mass density of water is 1000 kg per meter cube. Okay, mercury. Okay, all the other substance, okay, we will give. Okay, selalunya water and also air, you need to know by your memory. Okay, so water 1000, sedang nak ingat 1000 kilometer pula, kilogram per meter cube. Okay, senang nak ingat. And air 1.23 kg per meter cube. Okay, kalau bandingkan water and also air, which one have more density? Air dengan udara, bukan air dengan air. Okay, dua-dua pun sama kan. So water and air, which one have more density? Water, sebab yang ni nilai dia besar. 1000, this is 1.23. So almost 1000 times lesser. Okay, 1000 times lesser. Okay, so this is what related to mass density. The second one, specific volume. Walaupun I tak bagi tahu dekat sini specific density, but this is a part of density. We call it as a specific volume. Okay, specific volume adalah V kecil. It's not actually V, it's actually a Greek version of V. Dia simbol dia macam ni. Maybe I lukis lah. Okay, sorry. So this is gamma. Dia macam ni. Simbol dia macam ni. Dia nampak macam gamma, tapi dia macam V. Okay, so it's a Greek V. So kalau V kecil, selalunya kita akan ingat as what? Velocity. Okay, velocity. Tapi kalau you tengok dalam exam paper, it's not given this V, tapi V kecil, selalunya dia akan bagi tahu it's a specific volume. Okay, it's not velocity, so that you won't miscalculate. Tiba-tiba gunakan, instead of V over M, you gunakan meter per second. So velocity. So silap. Okay, so this is actually easy to remember because it's inverse of mass density. 1 per rho. Yang ni rho, yang ni 1 per rho. Okay, so the unit pun, yang ni kilogram per meter cube, yang ni meter cube per kilogram. Terbalik. Okay, so the definition is the number of cubic meters occupied by 1 kilogram of particular substance. So 1 kilogram, 1 kilogram of particular substance, dia boleh occupy berapa banyak meter cube. So berapa banyak meter cube. So that's the definition. Okay, for a gas, dia lain sikit. Dia bergantung kepada temperature and also pressure. So meaning it can have a same mass, same volume, tapi kalau surrounding temperature is different and also the pressure is different, dia punya specific volume of the particular gas akan berubah. Walaupun volume dia sama, mass dia sama. Okay, that's what. So gas dia special sikit. Okay, special sikit. The density of gas is proportional to pressure and inversely proportional to temperature. Okay, apa ni? Proportional maksudnya? Dalam bahasa Melayu apa? Okay, I pun belajar bahasa Melayu dulu. Okay, science. I apa? Campur. Okay, form 5 belajar dalam bahasa Melayu. Tiba-tiba pergi form 6, bahasa Inggeris, pening. Okay, kami bangsa yang jadi apa? Tikus eksperimen. Okay, guinea pig. Okay, so proportional maksudnya berkadar terus. Okay, dalam bahasa Melayu berkadar terus. Okay, so the density of gas is directly proportional to pressure. Maksudnya kalau pressure increase, the density of gas pun increase. So that is what we call as a proportional, directly proportional. And inversely proportional maksudnya berkadar songsang. So to temperature, meaning the density of gas will increase if the temperature decrease. Okay, dia macam opposite lah. Okay, and the unit is meter cube per kilogram. Okay, so far ada soalan dua ni. Ya. Yeah.
Kalau water 1000 but mercury pun lagi tinggi ya, 13,000.
Ya, betul.
But how, kenapa water ada free surface and water ada free surface, tapi mercury kalau dia jatuh pecah dia merebak.
Ya, tapi dia still ada surface. Still ada surface tension. Surface tension, kita panggil surface tension. Dia still ada. Dia takkan jadi macam water, dia akan pergi tanpa arah kan. Dia still akan ada kat satu tempat tu. Okay. But the properties dalam tu, it can break. Dia boleh break. Tapi dia takkan macam merebak. It will be in one particular. You gabungkan, you ambil pen or what, you push, bagi dia campur, dia akan cantum balik. Dia akan cantum balik. So that's the advantage. Tapi kalau tengok mercury is 13 times more than water. Dia lagi berat actually. Okay. Ada soalan lain? Okay, so physics is actually interesting. Tapi it's not to study in lecture. So I always encourage whatever things that you don't understand, go to YouTube. So dalam YouTube dia ada banyak video. Okay, dia ada banyak video yang you boleh tengok animations. Okay, so I continue. Ada soalan lain? Tak ada? Okay, kalau ada soalan nanti boleh tanya. Okay, so we go to another two types, specific weight. Okay, all these terms you will be seeing in the questions. later. Okay, later. Okay, so I just expose you to all these terms first, so that you biasakan diri dengar perkataan-perkataan ni. So specific weight, okay, specific weight gamma. Ini adalah simbol gamma. Ini bukan simbol gamma. Ini simbol V actually. Tapi dia nampak lebih kurang. Cuma dekat bawah tu dia macam ada curve. Okay. So gamma is a Greek symbol for specific weight. Is defined as a weight of substance per unit volume. Okay. You know mass can be converted to weight. Macam mana? Kita tengok dalam last week. How you can convert mass to weight? Kali dengan gravity. Okay, gravity. Okay. Always kita ada misconception that weight is mass. Kan? Kita ada biasa layman term. What is your weight? Tapi kita cakap dalam kilogram. So weight supposed to be in Newton. Okay, supposed to be in Newton. Kalau tengok dekat sini Newton. Okay. So weight is not in kilogram, but weight is in Newton. So you can have specific weight, something to do with weight. So weight of the substance per unit volume of substance. So you are taking one particular volume and you are taking a weight of the substance, not the mass. Bukan dalam kilogram tapi dalam Newton. Okay. So weight per unit volume, so mass per unit volume times with gravity. So rho kali G. Okay, depends kat mana. So kalau you ada dekat bulan, so gravity dia lain. So kalau you ada atas gunung, gravity dia actually kurang daripada waktu you ada dekat surface. So, walaupun is negligible. Okay. So you always remember, lagi dekat you dengan teras bumi. Okay, the earth core. So your gravitational force you are experiencing will be higher. Okay, so kalau lagi jauh, okay, you atas bukit, atas gunung Everest, 8,000 plus meters. So your gravity on top of the hill will be lesser. Okay, so that you need to understand. So when you are having weight, is always related to gravity and where you are measuring that. Okay, so kalau your lab is above the hill, so the value will be different when you are in the surface. Okay, so here the unit will be Newton per meter cube. Sebab tadi kilogram per meter cube, yang ni Newton per meter cube. Okay, so these are some of the typical values that you will be using, and normally all these values will be given. Okay, dalam exam, you just need to know how to use the values. Okay, so this is specific weight, and you have another term, specific gravity, ataupun kita panggil as relative density. Okay, all these four terms are related to densities. Okay, so specific gravity is defined as the ratio of density of a substance to the density of some standard substance. Ini adalah ratio. So kalau ratio, selalunya kita tak ada unit. So it's a dimensionless quantity, and we always will compare the particular density to water, H2O. Okay, usually water at 4 degrees Celsius. So kalau you nak tanya kenapa 4 degrees Celsius, so it's not ice and it's almost becoming a solid. So that's why we are taking 4 degrees Celsius. Okay. Okay, tadi kita tengok particular substance. Now we are going to ideal gas. Ideal gas, apa tu ideal gas? Siapa tahu apa tu ideal gas? Dalam bahasa Melayu apa? Gas? Gas apa? Gas ideal. Okay, gas ideal. Betul lah. Sorry, betul lah yang tu. Tapi I think ada satu lagi term. I pun dah lupa dah term tu. Siapa ingat? Anyone? Ideal gas tak apalah. Okay, by ideal gas, I think some of the gas are categorized as ideal gas. Okay, so it's already determined by the engineers. So, okay, this particular gas belongs to ideal gas. Okay, this particular gas are not belongs to ideal gas. Memang dah ada list tu. Okay, so ideal gas is gases that fulfill the equation of state. Okay, so equation of state is equation for the relationship between pressure, temperature and density. Okay, dalam equation of state kita selalunya gunakan pressure, temperature and also density to calculate that particular ideal gas. Okay, so actually dalam ada banyak thermodynamic tables. Okay, thermodynamic tables. So ada satu table untuk ideal gas. Okay, so simplest and best known equation of state. Ingat lagi tak formula ni? PV equals to nRT. Okay, so this is the ideal gas equation. For ideal gas, you are calculating all the terms, the pressure, temperature and density using this. PV equals to RT. Okay, ataupun P equals to rho RT. So this is actually conversion. Tadi kita tengok V is actually 1 over rho. So you dapatlah formula ni. Okay, so all this thing you can see here. Okay, R adalah gas constant. Gas constant ada dalam your scientific calculator. Constant berapa? Kita boleh tengok. Constant 24 kot kalau tak silap. Boleh tengok dekat the cover of constant 24. Cuba check. Nanti dalam exam jangan cakap I tak bagi value R. Value R ada dekat you punya calculator. Constant berapa? 27. Constant 27. Constant 27 adalah value R. Berapa value dia? Cuba check. Ya, 8.31. Ada ni times 10 to power tak ada. Okay, so gas constant adalah 8.31. Selalunya kita ambil 2 ke 3 tempat perpuluhan lah. Okay, so R adalah 8.31. So you just need to replace. So jangan bagi tahu sir tak bagi. Okay, so it's already available. Okay, ideal gas equation holds for most gases. So most gases listed under ideal gas category. Okay, so you boleh Google tengok. So what are the ideal gas? Okay, I letak dekat sini. Okay, however, dense gases such as water vapor and refrigerant vapor. Okay, so inside your aircon, so you have refrigerant. Apa tu refrigerant? Okay, yang ni pun ada jugalah soalan pernah keluar dulu. What is refrigerant? Okay, bahan cecair penyejuk. Okay, dalam aircon ada kan? Selalu kalau you beli, dia cakap R32. Okay, R32. Ada kan? So ada juga satu lagi term. So all that are referring to refrigerant. Okay, inside your vapor. Apa bahan penyejuk yang digunakan dalam aircon? Okay, so depends. Okay, so all that are not treated as ideal gas. Sebab dia tak memenuhi ideal gas equation. Okay, that's the thing that you need to know lah. So ideal gas ni, you kena gunakan ideal gas equation to calculate. Okay. Okay, some of the other terms that we are looking. Okay, viscosity. Apa tu viscosity? Ada belajar tak waktu fizik? Okay, viscosity is kelikatan. Okay, so minyak pun ada kelikatan dia kan? So kalau you tengok petrol dia likat ke tak? Tak. Tapi minyak enjin dia likat. So all these liquids they have different viscosities. Okay, so viscosity is a property that represents the internal resistance of a fluid to motion. So macam mana selalunya kita akan tengok viscosity, kita ambil ambil the particular cecair, kita letak in between the fingers, then you try to test whether dia ada resistance ke tak. Kalau dia susah nak move, meaning the viscosity is high. So itu yang dia bagi tahu, internal resistance of the fluid to motion. So ada motion kan? So ada motion, so meaning you have a internal resistance. Kalau water, senang je. So meaning the viscosity of water is very less. Okay. So you boleh tengok dekat sini lah. So actually I'm not really going through this. Tapi some of the yellow highlighted stuff, a constant parallel force, tangential force. So ada satu force dekat sini. Okay. And you have a shear stress, you boleh baca. So if you don't understand, you can ask me later lah. Okay, during our discussion. Okay, so I will try to explain. I just don't want to confuse you too much. I try to give you some info only lah. Tapi shear stress can be calculated using this formula. Okay, tau equals to force over area. Okay, tau is actually shear stress or the tangential force. Okay, so formula dia. Okay, for your level, diploma level, you just kena tahu some of the formulas related to all these things. Okay, so like this. So this is the important formula. So kalau you ada habit untuk buat short notes. Okay, short notes bukan toyol short notes. Okay, short notes. So try to take all these formulas and write it down separately. So waktu you nak buat latihan, you want to answer questions, so you boleh refer to all the formula. Dia macam list of formulas lah. Okay, so instead of you buka balik all the lecture note, you pun tak tahu banyak sangat formula kan. So write it down. Shear stress or tangential force is actually tau equals to F over A. Okay, so this is something related to viscosity. Soalan yang famous juga. So explain what is viscosity. Boleh tak you answer? So boleh lah you lukis benda ni. So viscosity is related to tangential force. So I bagi tahu explanation yang simple. Okay, how you can test a particular oil. So letak in between your thumb and also index finger and you try to rub. So you boleh lukis lah. Tapi lukis bagi saya faham. You jangan lukis macam simbol tu. Saya pun tak tahu apa benda. Ini apa, mini love. Jangan buat mini love dalam exam. So try to answer technically. Okay, so boleh baca sikit lah. But I just explain some of the formula that you will use selalunya. Okay, formula ni. Okay, du over dy. So u always we refer, u ataupun v kecil selalunya kita akan refer as velocity. Okay, so velocity over a particular distance, y adalah distance, okay, equals to v adalah velocity yang besar, okay, over a particular distance. Okay, tulis formula ni, or if you have highlighter, highlight formula ni. Okay, yang selalunya kita akan gunakan. Okay, and okay, dB. Okay, formula ni. So you rearrange the formula. Okay, so rearrange the formula, you dapat yang ni. Okay, and you boleh dapat formula ni. Okay, so what this formula is saying, the rate of deformation is directly proportional to shear stress. Okay, so you ada, yang ni adalah shear stress, symbol tau is directly proportional to rate of deformation. So maksudnya yang ini adalah rate of deformation. Du over dy adalah rate of deformation, ataupun kita panggil juga as velocity gradient. Okay, these are some of the terms yang, so beside this, tulis velocity gradient or rate of deformation. So some of the question dia akan cakap rate of deformation. Some of the questions it will say velocity gradient. Okay, So yang lain is just for your information. You boleh just baca. If tak faham, you boleh tanya saya. Okay, so another important question. Okay, selalunya subjek ni because it's dealing with basic. Sorry ya. Okay, because the subject is dealing with the basics of physics, so dia akan tanya banyak soalan dari chapter 1 and chapter 2. Okay, dalam exam. Tapi soalan tu dia tak ada banyak markah lah. So only few like 2 marks, 3 marks. But it's still important. Okay, fluid for which the rate of deformation is linearly proportional to the shear stress is called Newtonian fluid. Okay, so selalunya soalan yang akan keluar, apa perbezaan antara Newtonian fluid and also non-Newtonian fluid. Okay, so kita akan tengok apa itu Newtonian fluid. So Newtonian fluid, kalau you tengok graf ni, so you have paksi ini shear stress or tangential stress tau, and rate of deformation du over dy. So kalau you ambil graf ni and you draw for a different fluid. Okay, so kalau tengok oil, so you have the graph like this. Okay, so keturunan dia tinggi, A over B. So keturunan dia adalah viscosity, okay, of this graph, tau over du over dy. Okay, so if you draw this graph, you can draw for different substance ataupun different fluid. Like here, oil, water and air. Selalunya kita akan compare antara tiga ni lah. Okay, apa itu Newtonian fluid? Okay, so most common fluids such as water, air, gasoline and oils are Newtonian fluid. Okay, and blood and liquid plastic are example of non-Newtonian fluids. Ini adalah example lah. Kita tengok dulu apa itu Newtonian fluid. Okay, a plot of shear stress versus the rate of deformation for Newtonian fluid is straight line. So maksudnya dia ada dua condition untuk you tahu whether it's a Newtonian fluid or not. First, dia kena straight line. Yang ni straight line tak? Okay, all these are straight lines, kan? Okay, so condition pertama dah met, and it must start from origin point. Mana origin point? Kosong dekat sini. Dia kena start dekat sini dan dia adalah garis lurus. Then it's already considered as Newtonian fluid. Okay, and viscosity kena uniform, and it's like independent lah. Sebab dia garis lurus, so keturunan dia sama. So the viscosity will not change. Faham tak? So apa condition Newtonian fluid? Okay, apa condition Newtonian fluid? Okay, dia kena start dari kosong. So pastikan dia start dengan kosong. Then second, straight line. So garis lurus. Okay, so all these are Newtonian fluid because it's starting from zero and it is straight line. Straight line maksudnya keturunan dia tak berubah. Okay, so this is for Newtonian fluid. Okay, okay, some of the important information berkenaan dengan Newtonian fluid. Okay, so it is fulfilling Newton's law of viscosity. Selalunya kita tahu Newton's first law, Newton's second law, tapi ada satu lagi law yang proposed by Newton, so which we call as Newton's law of viscosity. So tadi kita tengok tau is actually directly proportional. Mana tadi? Tau is directly proportional to du over dy. So rate of deformation is directly proportional to shear stress. So kalau you nak buat persamaan, you kena kali dengan satu pemalar. Okay, so which is mu. So mu is coefficient of dynamic viscosity. Ada tak dalam kalkulator mu? Ada kan? So apa-apa coefficient selalunya ada dalam the cover of your calculator. Tapi I need to tell you, you are not allowed to bring your calculator cover to your exam, final exam. So kena hafal nilai R tadi. Okay, Sebab because of your seniors lah. Ramai yang tulis. Okay, so some of the important formula selalunya kita tertengok kan. So you only are allowed to bring your calculator. Saya bagi tahu siap-siap lah. Jangan nanti cakap, oh sir bagi tahu hari tu semua ada dekat cover, tapi cover tak boleh bawa. So nanti rajin-rajin akan keluar, pergi ke tandas. Dia pergi tandas berjemaah kan. So nak pergi tengok. Saya pernah jadi student, saya tahu lah. Okay, so try to remember tadi nilai R, nilai mu. Okay, kalau boleh itu saya akan cuba bagi dalam exam. Okay, dalam kertas soalan tu saya akan bagi tahu lah, so that you tak buat dosa. Okay, so dosa. Okay, so dosa-dosa tu kita tak nak, kita dah cuba elakkan. I try to give. Okay, ataupun waktu exam saya ada dekat sana, you just call me and ask, I will tell you. Okay, I bukan kedekut markah. I will try to help as long you understand. Okay. Okay, so coefficient of dynamic viscosity mu tadi berapa value dia? Kalau tengok dekat cover. Siapa? Constant berapa? Constant? 37. Berapa? Constant berapa tadi? Syntax error? Tertekan something kot. Ada tak? 103? Tak ada? Tengok cover tu. New one. Tengok. Ayo tengok. Wah, ada banyak, patutlah. Okay, I think constant 33 kot kalau tak silap. Constant 33 berapa? 1.2566. So kalau tak, saya akan bagi dalam exam. Okay, so you just use the value lah. Okay, so coefficient of dynamic viscosity. So tau equals to mu du over dy. Okay, this is another formula that you need to remember. Okay, so highlight lah formula ni. Okay, that you will use in your question. Okay, so you boleh baca lah yang ni. So change in speed. Okay, change in speed du over dy is a velocity gradient. Is a measure of change in speed. Liquid experience, and thus dia ada satu term shear rate. Okay, rate selalunya berkaitan dengan masa. Okay, berkaitan dengan masa. So at particular time, berapa banyak deformation is happening, so berapa banyak force is translating. So that is what we call as shear rate. And we have shear force acting on a Newtonian fluid layer. Newton's third law. For every action, there's an equal and opposite reaction. Okay, so it's fulfilling. Shear force is fulfilling Newton's third law. Formula untuk shear force adalah Newton's third law. Apa formula dia? Ingat lagi tak? Newton's third law. F equals to ma. Okay, force equals to mass times acceleration. Okay, so you just ganti yang ni, F equals to tau A. Okay, so M you tukar jadi tau. So F equals to tau A. So yang ni you just ganti. So tau adalah mu du over dy, mu du over dy kali dengan A. Okay, ini adalah satu lagi formula yang you akan selalu gunakan. So A is the contact area between plate and the fluid. Okay, so ada soalan. I tahu ada banyak benda yang kita belajar. So maybe it's still confusing. Okay, but you just go and read first. If you have other questions, you can ask during the discussion. Okay, so tadi kita tengok Newtonian fluid. Now we are seeing non-Newtonian fluid. Okay, from gambar ni, kenapa kita consider yang ni as non-Newtonian fluid? Tadi dua condition. Satu, start dari kosong. Okay, start from origin. Second, must be straight line. So yang ni Birmingham plastic. Birmingham pula. Oh, ini apa? EPL punya fever kan? Okay. Bingham plastik, sorry. Bingham plastik. Kenapa yang ni bukan Newtonian fluid? Straight line tak? Straight line, but it's not starting from origin. Okay, so Bingham plastik is non-Newtonian fluid. Pseudoplastic, kenapa? Start dari origin, tapi bukan garis lurus. Okay, so it's a curve. So meaning the gradient is not uniform. Sebab itu tengok dia menurun. Sebab tak sama. Okay, so yang ni Newtonian fluid because it start from origin and straight line. Dilatant, kenapa? Bukan Newtonian fluid. Okay, start from origin but not straight line. Okay, so some of the example, paint. Okay, paint, toothpaste, honey, blood. Selalunya something yang very thick lah. Something yang very thick. Jangan. Okay. So paint, selalunya dia kelikatan dia berlainan. So we consider it as a non-Newtonian fluid. Toothpaste, okay, honey, blood. Okay, so all these are some of the example. Okay, so soalan berkenaan dengan yang ni. So it can be explain what is Newtonian fluid and non-Newtonian fluid. Okay, the second, give examples. Okay, example tadi ada. So non-Newtonian fluid ada dekat sini. So Newtonian fluid tadi kita tengok oil, water, air, all that are considered as Newtonian fluid. Okay, so anything else from here? Okay, so boleh baca lah yang lain. Okay, so coefficient of dynamic viscosity ataupun kita panggil as absolute viscosity. So memang ada banyak benda dekat sini, but I just want you to focus on the formula. Okay, for now you just try to remember the formula. Okay, so yang definition ni selalunya kita akan tanya dalam exam. Okay, so what's in your syllabus, how you can apply all this formula to find the values, the answers. Okay, that's the thing that we will discuss. Okay, so coefficient of dynamic viscosity mu, yang ni yang tadi ada dalam calculator tadi kan. So it's actually shear force per unit area. Okay, force per unit area. So meaning it's something to do with the pressure. Okay, so pressure adalah force per unit area required to drag one layer of fluid with unit velocity. Yang ni semua tak perlu ingat lah, but you just need to know. So it's actually a measurement of fluid's internal resistance to flow. Okay, so kalau you nak push the particular fluid in one particular direction, macam mana dia bergerak? Okay, so that is what actually measured by the coefficient of dynamic viscosity. Okay, ini adalah formula dia. Okay, mu can be tau over du over dy. Okay, dari formula tadi. Ataupun force over area over velocity over distance. Okay, or force times time over area, ataupun mass over length times time. So all this can be asked. So depends on what information is given in the question. Okay, selalunya dalam soalan nanti kita akan tengok few example. So dalam soalan tu katakan dia bagi mass and length, suruh you cari time. So gunakan formula ni. Macam tu lah. So kalau dia bagi force, area and velocity, suruh cari distance, you gunakan formula ni. Okay, so formulas normally will not be given. So you need to know by yourself. Tapi tengoklah, kalau bernasib baik, so maybe akan bagi satu appendix of formula. Kalau saya bagilah. Okay, so see if I give. Kalau nak remember, sometime will be art, because you will be the first batch that I will be teaching face to face, and akan buat final exam face to face. Yes, kena cakap lah yes kan. Okay. So belajar face to face, one advantage I can explain to you. Okay, and suppose you boleh understand better, lab pun face to face. Tapi cuma kekurangan dia dari segi exam lah. So duduk dalam bilik apa? Exam hall yang sejuk tu sambil gigil 3 hours. Apa yang you belajar pun you akan lupa. Okay, so maybe I will try to help you with the appendix. I'll give you a set of formulas that you can use. Okay. This is the formula. So unit is Newton seconds per meter square. So ataupun kilogram meter per second, second per second, second per second, or Pascal second. Okay, so all these are some of the units for coefficient of dynamic viscosity, and we have another term called coefficient of kinematic viscosity. Ini lagi satu bentuk V, lagi satu bentuk V dalam Greek. Okay, so all these are some of the terms that will be used. So you just need to expose yourself. Okay, so it's actually ratio of dynamic viscosity to mass density. So kita tengok tadi what is dynamic viscosity. Okay, dynamic viscosity adalah mu. Okay, over mass density. Kita tahu adalah rho. Okay, so measurement, the units are meter square over second, and these are some of the typical values. So explanation is not required for your level. Yang ni just for your understanding. Okay, understanding that this kind of terms exist, wujud. Okay, dalam thermal science. Okay, so more about viscosity. So I just cover important part. Okay, so viscosity of a fluid depends on both temperature and pressure, although the dependence on pressure rather weak. Okay, so yang ni dia berkaitan dengan temperature and also pressure selalunya, because different temperature, kalau kenapa, okay, I nak tanya some question lah. Kalau you boleh answer, I tak tanya dalam soalan, dalam exam. Kalau you tak boleh answer, I tanya dalam exam. Okay tak? Okay, kenapa kita perlu buat servis kereta? Every 3 months, every 6 months. Why? Kenapa you isi minyak hitam tu you guna sampai habis? Kenapa every 6 months or after you reach particular kilometers you need to change the engine oil ataupun brake oil? Oh, ada technician.
Untuk memastikan pemanduan yang selamat.
Cik. Ini bukan kelas keselamatan jalan raya. Okey, betul lah. Answer dia betul. Okey, tepuk tangan. Okey. Okey, so you nak pastikan you jalan dengan selamat. Tapi kenapa nak selamat? So, enjin dia licin dalam tu, okey? So, sebab dalam tu ada banyak alat kerja, so you nak pastikan ada pelincir. Okey, betul? Okey? Tapi dari segi viscosity macam mana? Kalau saya tanya dalam exam, macam mana you akan jawab? You tak boleh jawab macam kawan you tadi. Nak pastikan you selamat sampai ke destinasi kan? Okey, betul yang tu. Tapi in terms of viscosity, ya? Okay, saya bagi satu. Okay, you are telling all the right answer, betul. Tapi it's not in terms of. So answer tu dia berkaitan dengan temperature and pressure. I bagi in. Ya. Ni dah nampak dah top student. Ya. Google ke? Regulate, okay. Regulate apa?
The temperature of the engine.
Regulate the temperature of the engine. Bukanlah aircon.
Aircon dalam kereta.
Dalam kereta, yang ni luar kereta. Okay. Okay, yang tu maybe coolant. So, maybe coolant. Kalau you gunakan coolant, maybe it's regulate the temperature, betul. Tapi minyak hitam tak ada kaitan dengan coolant.
Kalau minyak hitam tu jadi dalam
minyak hitam lagi likat, dalam tu jadi panas. Okay, it's actually terbalik. Kalau enjin you terlalu panas, minyak hitam tu akan kekurangan kelikatan over time. Betul lah, tapi terbalik. Okay, terbalik. So you always understand kenapa after certain kilometer you kena tukar. Sebab after certain kilometer enjin you akan jadi panas. Then kelikatan minyak dalam tu dia akan jadi talikat lah. So kalau talikat tu you akan gunakan more minyak. So you akan ada pembaziran and enjin you akan rosak. Sebab dia jadi pelincir. Pelincir dia suppose kena licinkan alat kerja dalam tu. Kan? So dia tak dapat buat kerja dia. So what you do? You flush out all the engine oil ataupun particular fluid, you gantikan dengan yang baru. Faham tak? So it's related to the temperature. So fluid, the viscosity of the fluid depends on the temperature. Pressure tak sangat. So although the dependence of the pressure rather weak. Okay. So for fluid, both dynamic and kinematic fluid depend on. Okay. So ini tak apalah. So not so important. Okay. What are the important stuff? Okay. Point number 4. Viscosity is caused by the coercive force between the molecules in fluid and by the molecular collision in gas. Okay, so kita tahu fluid ada dua. Apa? Fluid tadi. Gas and liquid. So ada dua. Okay, so viscosity untuk liquid adalah coercive force between molecule. So you boleh baca dekat sini lah. Okay. So kalau pelanggaran antara molekul dalam liquid adalah tinggi, so kelikatan akan lebih. Okay, akan meningkat. Okay, but dalam gas, molecular collision, lagi banyak molekul berlanggar antara sesama sendiri, so lagi banyak kelikatan gas. Faham tak? Okay, so kita baca sikit dekat bawah. Okay, liquid viscosity decreases with temperature. Ini yang I bagi tahu tadi lah. Okay, so your example is your engine oil. So when the temperature increase over time, okay, setiap hari you pandu kan. So that's why they always encourage before you go long distance to service dulu kereta. Because of that. Because maybe inside the town you already used for so long until the liquid already not viscous. So kalau you nak jalan jauh, so let's say you are going from Perlis to Johor ataupun dari Perlis ke Sabah. Tak boleh kan? Perlis ke Johor lah paling maksimum you boleh pergi. So 800 plus kilometers one way. Pergi balik. So 1600 kilometers. So selalunya minyak hitam kita tukar berapa kilometer sekali? 20? So it depends on the fluid lah. Tapi minyak hitam selalunya best 5000 km once. Okay, and depends on the minyak hitam jugalah. Ada banyak kan, fully synthetic, semi synthetic. So depends on your minyak hitam. Tapi always 5000 lah, 5000, 7000. Fully synthetic maybe 10,000. Okay. So tukar dulu because liquid viscosity decreases with temperature. Kenapa viscosity of the liquid decreases? Because the molecule possesses more energy at higher temperature. So kalau temperature tinggi, molekul pun bergerak dengan banyak lah. Okay, and they can oppose the large coercive intermolecular force more strongly. So meaning antara molekul dia ada intermolecular force kan. Okay, daya tarikan antara molekul. So kalau dia temperature, dia akan pecahkan intermolecular force. Okay, so meaning it will oppose a larger coercive intermolecular force more strongly. As a result, the energized liquid molecules can move freely. Okay, it depends on the intermolecular force. Okay, so what it is saying, because the coercive intermolecular force is decreasing, so the molecules can move freely, so the viscosity is lesser. So itu yang dia bagi tahu dekat sini lah. Kenapa kalau temperature meningkat, liquid viscosity akan menurun. But gas dia terbalik. Sebab gas viscosity increases with temperature. Lagi banyak temperature, so gas viscosity akan meningkat. Dia terbalik dengan liquid. Kenapa? Because in a gas, the intermolecular forces are negligible. So daya tarikan antara molekul tak ada, or boleh diabaikan. It can be negligible. And gas molecules at high temperature move randomly at higher velocity. So lagi banyak temperature, so molekul akan bergerak secara rawak, kan? So it will move very randomly. As a result, more molecular collision per unit volume per unit time. So dia akan ada banyak pelanggaran. Sebab temperature, so dia bergerak dengan rawak. So as the temperature increase, it will move faster. So kalau dia move faster, dia tak boleh escape, kan? So dia akan langgar antara sesama sendiri. More. Kalau temperature less, maybe pelanggaran 100 kali. Kalau you increase the temperature from 100 to 200, so 100 times tadi dia langgar, sekarang dia langgar maybe 500 times. So more times it is colliding. So the more molecular collision per unit volume. So dalam unit volume is not changing. Time pun maybe like 1 minute. Okay. So therefore the greater resistance to the flow. So lagi banyak dia langgar, so lagi banyak benda tak boleh lalu in between. So it is causing a greater resistance to the flow. So that's why gas viscosity increases with temperature. Okay tak? Faham? Okay. So you boleh tengok dekat sini. Okay, viscosity over temperature. Okay, so liquid, kalau temperature lagi meningkat, the viscosity of the liquid will go down. But for gas, it will increase. Yang ni boleh tengoklah some of the, yang ni dari thermodynamic table. Saya ambil dari thermodynamic table. Tengok yang atas ni adalah liquid ke gas? Atas ni liquid sebab dia macam ni. So castor oil, tengok yang ni adalah gasoline, minyak petrol, kerosene, minyak kapal terbang, okay, mercury, benzene, crude oil, minyak mentah, okay, castor oil apa castor oil yang digunakan untuk rambut tu, okay, glycerin, yang ni semua adalah liquid. Okay, so you can see the graph as the temperature increase, so the graph is going down. Tapi untuk gas, tengok helium, carbon dioxide, air, hydrogen, dia meningkat walaupun tak banyak, but it's increasing. Okay, so ini adalah some contoh. Ada lagi tak? Okay, 10 minutes. So we will see few example. Okay, ini adalah contoh soalan yang boleh ditanya. Okay, normally the questions will be like this. So nanti saya akan bagi tutorial. So dalam tutorial you akan tengok banyak lagi soalan lah yang almost similar like this. Okay, so you can see. Okay, abaikan answer ni. So try to find information from. So relate with whatever you learned earlier. So tadi kita belajar banyak benda. I think I nak minta you remember pun it's not fair because we learn a lot of stuff. Okay, but when you do examples or when you do questions, you will indirectly remembering a lot of stuff. So tadi I bagi tahu, for this course I am not testing your mathematics. Okay, I want to test your understanding, and it's not about how you define this, define that. So tadi kita tengok absolute viscosity, specific density. I am not going to ask you what is that. Tapi you kena tahu macam mana nak gunakan untuk cari answer. Okay, that's the important stuff. So tadi you dah tulis a lot of formula. I suruh you highlight. So nanti balik ke hostel. So try to write it down. So chapter 2, apa-apa formula yang kita discuss dekat sini, so try to write it down in a separate paper. Next time bring. For the next class you bawa. So nanti ada soalan tu, you terus refer to your short notes. Okay. So saya jawab soalan ni. So ada 10 minit lagi, we try to answer 1 or 2 question. Kemudian the remaining, I think ada dalam ni ada 4 soalan. So the remaining question I will give you in the video form. Okay, so try to answer. Alright. Okay, so in a fluid, the velocity measured at the distance of 75 mm from the boundary is 1.125 meter per second. The fluid has absolute viscosity 0.048 Pascal second and relative density 0.913. What is the velocity gradient and the shear stress at the boundary assuming a linear velocity distribution? Okay, so first thing, when you receive this kind of question, write the information. Macam information ni, so velocity is okay, velocity mana velocity ni? Okay, velocity is here. Okay, so u. Okay, u ataupun this is changes in u. Okay, changes in velocity. So is 1.125. So tulis dekat sini u equals to 1.125 meter per second. Okay, make sure you convert it to SI unit. Okay, then apa lagi? Distance. Okay, distance maybe it can be d. Tapi dia bagi dalam 75 mm. Apa SI unit untuk distance? Meter. So convert millimeter to meter, siap-siap. Tulis dekat sini. So you dah convert siap-siap. Okay, so d equals to 75 mm equals to 0.075 meter. So tulis terus. Okay, so it's easier for you. Then you have a absolute viscosity 0.048. So absolute viscosity tadi coefficient of apa tadi? Tadi kita tengok. So coefficient of dynamic viscosity. So that is what we call as mu. Okay, so mu is 0.048 Pascal second. So unit is given, unit dia betul. Selalunya dia akan bagilah macam ni. So they will, unless they give all the other thing and ask you to find the absolute viscosity, then you boleh carilah. Tapi unit dia selalunya sama. Okay, Pascal second ataupun tadi kita tengok so Pascal second, ada Newton second per meter square, then kilogram meter per second, second per second, ataupun kita selalu gunakan Pascal second. Okay, then one more, relative density. So relative density is you don't have a unit, so 0.913. Okay, so no unit. Okay, so these are the stuff that you already got. Okay, so sekarang you boleh cari velocity gradient. Tadi formula dia apa? Velocity gradient. Velocity gradient? Velocity gradient adalah yang ni. Okay, changes in velocity over changes in distance. Okay, so you apa simbol ni I dah lupa dah. Matematik ada kan? Ingat lagi simbol ni. So tak apalah, kita letak du over dy. Okay, so du over dy, okay, so it's actually changes in velocity over changes in distance. Okay, so yang ni adalah velocity gradient. So yang ni boleh cari. So you boleh cari dekat sini. And shear stress. Shear stress adalah tau equals to mu du over dy. Okay, so tadi kita tengok untuk cari ni So you boleh gunakan a lot of stuff. So depends what you want to find. Okay, so based on that you boleh cari yang ni. Okay, first you find du over dy. So velocity divide by the distance. So 1.125 meter per second. Okay, meter per second divide by 0.075 75 mm, convert ke meter. Okay, so you dapat du over dy adalah 15 per second. Okay, so you cancel meter dengan meter, so tinggal per second. So 15 per second. Okay, then you already found this. Then second dia suruh cari shear stress. So shear stress tadi formula ni lah. Mana tadi? Yang ni, shear stress formula ni. Okay, so tulis. Kalau you tulis asing, so you tak perlu refer balik lah. Okay, so tau equals to mu du over dy. Okay, so you ganti balik. So mu you dah tahu 0.048 kali dengan 15. Okay, so 15, so you dapat so yang ni you cancel S dengan yang ni, so you dapat Pascal. So 0.72 Pascal. So this is your pressure. Okay, so ini adalah satu example lah yang you boleh buat. So ada lagi 3 example. Nanti saya bagi video. So kita akan discuss next week. Okay. Okay, so ada soalan? Any question before we finish? Lagi 5 minit. Okay, so for this week, Friday kita tak ada kelas sebab kita akan buat Synchronous. So saya selalunya akan bagi add puzzle video. The video dalam add puzzle, so you listen. So I normally will give 1 week. Okay, 1 week for you to listen. Meaning, kalau saya bagi hari ni, kita akan discuss next week Friday dalam Google Meet. Okay, meaning Friday 1 hour class tu memang tak ada lah. So memang tak ada physical. Physical only for Wednesday. Sebab 1 hour I nak set everything, panggil nama. So I selalu suka panggil nama because I want to kenal you. Senang nak kenal. So senang nak sebut nama kan. Kalau tak QR code pun you just scan untuk kawan juga kan. So I selalu panggil nama. Okay, so we want to settle all that. So memang 1 hour tu kita tak boleh discuss a lot of stuff. So better kita buat Google Meet. Okay, for Friday. Tapi lepas tu you kena main sini pula. Kan ada kelas kan? Dekat DK. So pandai-pandai lah. Okay. So ada soalan? Okay, tak ada soalan. I panggil balik nama yang tak ada tadi. Ajwad ada? Ada. Sorry. Oh, tadi tak ada pula. Okay. Okay, Muhammad Amar tak ada kan? Okay, Muhammad Faiz bin Uthman tak ada. Muhammad Firdaus bin Muhammad Farid tak ada. Parameswaran ada? Parameswaran tak ada. Syed Azimi tak ada juga. Tiwagar tak ada juga. Okey, Zarik Iskandar demam. Okey, so thank you. We will meet on Friday next week physical. Okay, boleh off.